Section 8.7 is base E and natural logarithms. E is an irrational number. It explains the natural growth. It's similar to pi. Pi is 3.14, but it goes on and on and on. It's an irrational number. E is the same way. E is about 2.71828. The natural log with the base E is written log base E of x is equal to y. Instead of writing the log base E, we abbreviate it, so a shortcut of log base E is written ln of x is equal to y. Now make sure that when you do that, you don't write it as ln, as ln, print it. Always do the ln as cursive, because if you print it ln of x, it looks like 1x, 1nx. So make sure you do it in cursive. ln of x is equal to y. An example over here, the log form, log base E of 4 is equal to y. Well, we are going to replace the log of E with ln. So ln of 4 is equal to y. To put it in exponential form, your base is E, so it's e to the y power is equal to 4. Example 1, write each exponential function in log function. So e to the x power is equal to 8. That would be log base E of 8 is equal to x. And once again, we're going to replace log base E with ln. So ln of 8 is equal to x. ln stands for natural log. So natural log of 8 is equal to x. Example B, ln of e to the 5th power. Well, we need to put the 5 in front, so that would be 5 ln of e. And ln of e is equal to 1. So that's something that you can put on your index card and memorize. Anytime you see ln of e, you replace that with 1. So we're going to replace ln of e with 1, and 5 times 1 is 5. Example C, e to the x power is equal to 9. We're going to put that as log base E of 9 is equal to x. And once again, we're going to replace log base E with ln of x is equal to 9. Example D, log base E of 0.1 is equal to negative 5x. Excuse me, yeah. Now, if you can go straight to the ln, you can certainly do that. You don't always have to write the log base E. If you can go straight to ln of 0.1 is equal to negative 5x, that is absolutely fine. Example 2, write each logarithm in exponential form. ln of x is about equal to 0.7741. To put it in exponential form, that ln of x is the same thing as saying log base E of x is equal to 0.7741. So to put that in exponential form, that's e to this 0.7741 power is equal to x. Example B, I'm going to go directly to put that in exponential form. My base is e. It's not there. It's invisible, that ln of 10, but it's there. So e to the x power is equal to 10. Example C, ln of x is equal to 2.1438. To put this in exponential form, the base is not there anymore. It's understood to be an e. So right there would be an e. So it's e to the 2.1438 power is equal to x. Now you try to do D by yourself. So that's e to the x power is equal to 18. Example 3, write each expression as a single log. Okay, single log means we need to put it in one log. Right now it's in two logs. It's in expanded form. 3 ln of 10 minus ln of 8. The very first thing we're going to have to do is we are going to have to put that 3 as the power. So that would be ln of 10 to the third power minus ln of 8. And then we need to evaluate 10 to the third power is 1,000. And that minus means to divide. We could have done 1,000 before we put it in division. It doesn't really matter. And the subtraction means to divide, so that's ln of 1,000 divided by 8, which is ln of 125. Now, what we need to do is we need to break the 125 down to the smallest possible base. What number to what power gives you 125? 5 to the third power. So I'm going to rewrite that as ln of 5 to the third power, put the 3 in front, so it's 3 ln of 5. And that is the single log simplified down. Example B, put it in a single log. The very first thing we're going to have to do is put that 2 in the second term, make it a exponent of 2. So that's ln of 40 plus ln of 1/2 to the square power plus ln of x. We're going to square 1/2 and get ln of 1/4. And then we're going to put in a single log where we multiply. That's ln of 40 times 1/4 times x, which is ln of 10x. Example C, to put in a single log, the very first thing we're going to have to do is put that 6 as the exponent. So that's ln of 8 to the 6 minus ln of 4 squared. Now, instead of getting the calculator and doing 8 to the 6, because you get some big number, we're going to keep it as 8 to the 6 and put it a single log. The minus means to divide, so that's ln of 8 to the 6 divided by 4 squared. Now what we want to do is we want to get our bases to be the same. We've got to convert that 8 and 4 to have the same common base. 8 is 2 to the third and 4 is 2 squared. So I am going to replace 8 with 2 to the third power. And then that 6 is the power it comes outside. And then we're going to replace 4 with 2 squared. And then put the power outside, the square power outside. Now to evaluate, we're going to do the power of a power. So that's ln of 2 to the 18th power divided by 2 to the 4th power. Now once you have the same base, when you're dividing, you just subtract the exponents. So that's going to be ln of 2 to the 14th power. And then we're going to put the 14 in front. So that's 14 ln of 2. Example D, you try to do this one by yourself. Okay. Because the natural base and the natural log are inverse functions, they can be used to undo or eliminate each other. If we first look at e to the ln of x is equal to x, well, the reason why e to the ln of x power is equal to x, if we put the ln in front, what we did right here, we'd get ln of e to the x power is equal to x. and then we're going to put the x in front. Whoa, sorry. So we get x ln of e is equal to x, and remember, anytime you see ln of e, it replaces that with 1, so x is equal to x. Equations and inequalities involving base e are easier to solve by using natural logarithms rather than common logarithms. Example 4. We're going to solve and then round to the nearest 10 thousandths. If you will notice this problem, the variable is in the exponent. So what we've got to do is, our goal is to get e to the negative 2x by itself. So the very first thing we're going to have to do is add 5 to both sides. So that's 4e to the negative 2x is equal to 8. And then we're going to divide both sides by 4. So we get e to the negative 2x power is equal to 2. Now, let's look at this. Can we convert our bases to be the same base? No, we cannot convert e to have a base of 2, and we cannot convert 2 to have a base of e. So last night's homework, when we were doing the common logs, we took a log of each side. Well, we're going to do the log, but it's going to be the natural log of each side. And how do you know to use the natural log versus the common log? Because of the e. So anytime there's an e, that means you're going to take the ln, natural log. So we're going to take the ln of each side. So that's ln of e to the negative 2x is equal to ln of 2. We are then going to put that negative 2x, bring it in front, and put it in front of the ln of e. And remember, anytime you see ln of e, you replace that with 1. So it's negative 2x is equal to ln of 2. We're going to divide by negative 2 on both sides. Using your calculator, we're going to plug that into the calculator, and we get 0.3466. The ln button on the calculator is right below the log button. Example 4b, we're going to solve. Again, our goal is to get e to the 4x power by itself. And the reason why you have to do that is because x is in the exponent. So you want to get everything away from there. So we're going to add 12 to both sides. Then we are going to divide by 3. So we get e to the 4x is equal to 9. Now we're going to take the ln of both sides, which is the natural log, bring the 4x in front, and anytime we see ln of e, that replaces with 1. So that's 4x is equal to ln of 9. Divide both sides by 4. Using our calculator, we get x is about equal to 0.5493. So practice plugging that in the calculator and make sure that you get 0.5493. Example C. Pause the recording and you try to work this problem by yourself. Okay, let's see how you did. Okay, example 5, we're going to solve again, but this time, if you notice, the problem doesn't have an e, it has a natural log. So this says 3 times natural log of 4x is equal to 4. Do we put the 3 to the power? Do we write it as ln of 4x to the third power? That wouldn't work because our goal is to get the ln by itself. So we need to get rid of that 3, so we're going to divide both sides by 3. So we get ln of, whoops, oh, sorry. Okay, divide both sides by 3. Okay, it doesn't want to cooperate with me. So let's just look at this problem. We're going to divide by 3, so we get ln of 4x is equal to 8. Now, notice on the left side is a natural log is equal to something. So what you're going to have to do is put this in exponential form. So that's e to the 8th power is equal to 4x. So we put this in exponential form. Using your calculator, the e to the x button is the second ln button. So you put in e to the 8th power and then divide each side by 4 and round to the nearest 10 thousandths, as that's the problem you should get. Alright, so we're going to put the 4 in front because we've got to get rid of that power. So that's 4 ln of x minus 8 is less than 4. Then we're going to divide each side by 4. So that's ln of x minus 8 is less than 1. Okay, now notice we have a natural log. If we have a natural log on one side, what we're going to have to do is put in exponential form. The base is e. It's not there, but it's understood to be there. So e to the 1 power, and because that's an inequality, we've got to flip the inequalities to say greater than x minus 8. Now, then we're going to add 8 to both sides, so that's e plus 8 is greater than x. Using your graphing calculator, put in e, so that'd be the second function ln, and that's to the 1 power. You have to put the 1, and then add 8, so that's x is less than 10.718. Put that in interval notation. Okay, let's read this problem. When Angelina was born, her grandparents deposited $3,000 into a college savings account, paying 4% interest compounded continuously. Assuming there are no deposits or withdrawals from the account, what would the balance be after 10 years? Okay, we need to look at, we have another formula for the compound continuous interest formula. That formula is A is equal to P times E to the RT power, where P stands for principal, E is E, R is the rate, and T is the time. So we're going to put the principal is 3,000 times E. The rate, remember we have to put in decimal form, so 4% is 0.04. Times T, 10 is our time. We first going to multiply 0.04 times 10 is 0.4. Using our calculator, we will get $4,475.47. Okay, same information, but part B, well, how long will it take the balance to reach at least $10,000? So this time, We need to find our t, and we know our a. So our a is 10,000. Our principal is 3,000. So our rate is 0.04. And this time we don't know our time. Okay, now we've got to get the e 0.04t by itself. So we're going to divide both sides by 3,000. We don't need a calculator. We could just cancel all these zeros and get 10 over 3 is equal to e to the 0.04t power. Now this is just like what we were doing earlier. We've got a variable in the exponent. When the variable's in the exponent, we have to take the natural log of both sides. Put the 0.04t in front, and ln of e turns into 1. So that's ln of 10 thirds is equal to 0.04t. Divide both sides by 0.04. And we get t is about 30 years. Part C, if her grandparents want Angelina to have $10,000 after 18 years, how much would they need to invest? So again, put the formula. Now this time our amount is 10,000, but we don't know the principal. And we know our rate is 4.04 and our time is 18. So this time, to get p by itself, we have to divide both sides by e to the 0.72 power, and we get about $4,867.52 is the principal that they will need to put into the bank. Okay, I did a few problems from the homework. Here's number 33. Okay, so we had to put the powers in the front. So that's ln of x to the 6 plus ln of 8. Single log, we're going to multiply. Okay, and here's number 43. Now our goal this time is to get ln by itself. Now the ln is on the right side. We've got to put this in exponential form. So exponential form is e to the 10 third power. Flip the inequality. It's less than 3x plus 4. We've got to solve for x, so we're going to subtract 4 and then divide by 3, and then it's just plugging in the calculator.